Right, so looking at decision version 5, this was decision version T for another group. It's a paper I've acquired rather than one that I've written. But same things. So first off, we are using Dijkstra, and we are going from Cardiff to Abergavenny. So from looking at the map, we have Cardiff at the bottom and we have Abergavenny right up at the top. So because it's Dijkstra, we need to start at the bottom. The other information that's given to us is all temporary labels. So all temporary labels is the bits that you crossed out, and then the corresponding route. So if we start at CA, it's going to take us no time to get from CA to CA, so that will be 0. Smallest thing not boxed is 0. So from here we can do that one, which is 13, and that one, which is 13. It doesn't matter which 13 you pick. So if we take that one first, 13 and 14 is 27. The next smallest 13 will be this one. So we have 25 and 24. So next smallest is going to be 24. From 24 we have a 35, we have that which will be bigger, and we have that which will be bigger. From here, our next smallest one, we've got this one at 43, we've got this arcing one up here, which is 57, we've got this one up here, which is 42, and that looks about it. Okay, so next smallest is back over here in this 27, but we can't go anywhere from it. Next smallest is the 35. So from 35 add 3 is smaller. So this crossed out bit here is our temporary label. Really important to leave that in. And we've also got our 49. This is our next smallest. So from here we've got 44. 43 is our next smallest. 43 add 13 is 56. 44 is our next smallest. That gives us 51 there, and gives us 50 here. So these two crossed out ones are the temporary labels that they're referring to in the question. Right, next smallest is 49. 49 and 11 is 60. So we know that we can go from Cardiff to Abergavenny in 60, but we're looking for the smallest route. So the next smallest thing on here is 50. 50 and 8 is 58. 50 and 20 is 70, which is bigger. The next smallest is 51. 51 add 8 is 59. Next smallest is the 58. 58 and 9 is bigger. And we finally got to the top. So, working backwards, sort of where the maths makes sense. 49 take away 8 is 51. 51 take away 7 is 44. Is that one. That one. That one. That one. So our corresponding route is going to be working up through our map. So corresponding route is going to be CA, PB, CE, SW, PP, LT, GO, and AG, and that has a length of 59 minutes, so just under an hour. We are then given some extra information. So before she leaves home, she finds out that the routes from BL to AG, so BL to AG is that one, and GO to AG, which is that one, are closed. So we can't go that way. So this is where understanding what Dijkstra actually tells you is really useful. So what Dijkstra is telling us is that the quickest way to RA is 58. And that is the route we can go in there. So 58 and 59. It tells us that the quickest way to here is 50. So from here, the other route that we could go in would be 50 to there and another 20. So 50 and 20 is going to be bigger than 58 and 9. So for part B, our new minimum travelling time is going to be different colour highlighter. Okay, right, so things that we know that we're going to have to get to this 50 because that's the only way to get in by one of those two routes. So to get to that 50, we would do a really similar route to the one we did before. So from here, we're either going plus 20 or plus 8 and 9. 8 and 9 is smaller, so we'll go that way. So we know that this is 58. So we can do 58 add 9. And our new route will be exactly the same as far as LT. And once we've got to LT, that's when we need to start thinking. So we've got CA, PB, CE, SW, PP, LT, and that's where instead of going up that way, we're going around this way. So we then go US, RA, AG. So looking at Dijkstra, we know that it takes us 58 to get there and another 9 to get there. So 58 add 9 should give us 67. So our new length is 67 minutes. And it does say the new minimum travelling time, not the extra. So that's it for question 2.